All right, DIY 18650 and YouTube. Just sitting here with the Mosfet spot welder, and I got a few things sorted out. I added a second truck relay, and because it has a common, and now we have a simulated gate driver, and I'm actually using the Mosfets properly. So we'll just go on into it, and I'll show you how it works. So first of all, why it worked before is just because I had so many MOSFETs. I was only requesting under 10% of them, of their power. So having a 1K pull down resistor, it was just giving the gate rail here a 0 volt signal. And then when you take the positive turn on signal away, it was enough to turn them off. But it was slowly damaging the MOSFETs, right? So what I did was, and what I'll explain, show you in a quick video with this light. This is a LED, can only light one way. So right now on this wire, you can see here, goes to the gate rail. I have it with a negative current right now, and I'll show you that by hooking this negative of the light on there and taking the positive electrode and then turning the light on. As you can see, I'll bring the camera in. That's negative. Positive was touched by the positive electrode cable. Whoop. So I'll show you if I just take this negative and now I put it over to here and I take the positive and put it on this leg, you'll see that there'll be no light because the diodes, the LEDs. And when I push the flip switch, I see a little flicker because the common gets disconnected, and then from the other relay, the capacitance will set the timing and trigger this relay. Okay, so this is important because when you want to drive MOSFETs properly and turn them on and use them properly, a driver gives, you have a pull down resistor, right, let's say, and it's keeping the rail at 0, or a soft negative. So negative with no current. You hit the positive with current and it turns the MOSFETs on. You take that away, you should be applying a hard negative, which means a negative with current, to fully saturate and turn them off. Okay, that's how you drive MOSFETs. So that's what this is doing. It's allowing them to drive. So I'll show you with the welds. If you guys are following my other videos, and I added longer cables, but I did a bunch of welds last night. There was no difference. It was still doing, big dirty welds compared to what we're doing now. And the welder would heat up if you did like 10 or 20 welds pretty fast. Not a lot of heat, but now there's 0 heat because I have so many MOSFETs. I'm still requesting very little of them. Oops, I should zoom that in. See how you guys like that. Doesn't matter how fast you go. There'll be absolutely no heat. The welds are just gorgeous. There's no burn marks. There's no nothing. I'm using not the proper copper, so I am having a little bit of sticking. But we'll order up some better stuff. Yeah, just beautiful. 2 layers of 0.2 nickel, pure nickel. Just beautiful. I'll try to put on an angle for burn marks. I don't see any. Just little gold marks, but nothing. Welder didn't warm up at all. It's the same temperature. And that's it. So as soon as I trigger I give it a positive 12 volts, hard 12 volts, turn the MOSFETs on, the relay disconnects that, and then the common comes back connected, and a hard negative is connected to make sure they turn off. I have a diode here for protection. I have a diode here coming across to take any back spike, back positive, and take it over to here. These diodes should be mounted over here, but I know it is what it is. You can tell from how I showed you with the light how that works. And the welds are just perfect. It's hard to see unless I zoom it in. But yeah, there you go. And I measure practicing with the strips because I know how they'll relate to a cell, and I'm inside, so it's just safer just to do. I like to do lots of welds. I don't just do 4 or 5. I do hundreds and hundreds of welds. And like I said before, the welder was heating up before. Absolutely zero heat. No heat at all. If I had a loloscope, or sorry, I don't know if I butchered that, but I'm going to order one, and I would like to, be able to show you that this stuff is actually working properly. But I will be having a PCB made by my buddy, so we are just going to do it properly. I just wanted to make sure that I could make this stuff out of junkyard parts and make it work, and obviously you can. Clearly had it working not properly, but it was working before, and it's working 100% now. And hope you guys liked the video. I'll do another video where what I'll do is I had the IRF 1404s, a lot of fakes out there. I think they also might be very finicky and blow up anyways if you don't have a driver. So now that I have this junkyard simulated driver, I'll build another welder. I'm pretty sure I have the parts from the ones that blew up. I don't know, somewhere, but we'll figure it out, and I'll make a build video so you guys can see step by step. Everything's just paralleled up, so it's not really too complicated. But I'll do a step-by-step video for you guys that want to do a junkyard build like this. And I'll get that back to you guys in like the next week or something. Hope everyone's having a good one. Cheers, guys.